National Electrical Code Section 314.29 addresses accessibility of junction boxes, conduit bodies, and handhole enclosures. It stipulates that these enclosures must be accessible without removing any part of the building or structure, landscaping, or paving. Accessibility should not require the removal or disturbance of finish, such as plaster, drywall, or paneling. The intention is to ensure that electrical connections and components within these enclosures can be readily inspected, maintained, or modified without causing unnecessary disruption to the building or its surroundings. This accessibility requirement is fundamental for safety and compliance, allowing for quick identification and resolution of potential electrical issues. National Electrical Code Section 314.4 C concerns the support of conductors within boxes. Specifically, it states that where one or more individual conductors are used as a wiring method, all conductors, including equipment grounding conductors and bonding jumpers, must be supported in accordance with Section 300.4. D. This section focuses on protecting conductors from abrasion where they enter or exit boxes or conduit bodies. Section 300.4. D provides specific requirements for bushing or other protection to prevent damage to conductors. The National Electrical Code permits connecting multiple number 14 grounding conductors together using a splice cap inside a subpanel and then extending a single number 14 wire to the grounding bus. However, it is crucial that the splice cap used is listed for this specific application. This means the splice cap must be designed and tested to safely and effectively handle the connection of multiple grounding conductors. Grounding conductors play a vital role in electrical safety. They provide a low impedance path for fault current to return to the source, which helps to quickly trip a circuit breaker or fuse, thus preventing electrical shock and fire hazards. When multiple branch circuits are present in a subpanel, each circuit must have its own grounding conductor that is properly connected to the grounding system. A subpanel, also known as a distribution panel, is a smaller electrical panel that receives power from the main electrical panel and distributes it to various branch circuits within a specific area of a building. Subpanels are commonly used in residential, commercial, and industrial settings to provide localized control and protection for electrical circuits. The grounding bus in the subpanel is a conductive bar that serves as the central connection point for all grounding conductors within the panel. The grounding bus is typically bonded to the metal enclosure of the subpanel and connected to the main grounding electrode system, which provides a direct path to earth. When connecting grounding conductors in a subpanel, it is essential to follow the requirements outlined in the National Electrical Code to ensure a safe and reliable electrical system. The code specifies the methods and materials that must be used for grounding and bonding, as well as the requirements for sizing and installing grounding conductors. The use of a splice cap to connect multiple grounding conductors is a common practice, but it is important to choose a splice cap that is specifically listed for grounding applications. These splice caps are designed to provide a secure and reliable connection that will withstand the stresses and environmental conditions typically found in electrical panels. Listed splice caps undergo rigorous testing by independent testing laboratories to ensure they meet the safety and performance standards established by organizations such as Underwriters Laboratories, (ORL), and the Canadian Standards Association, or CSA. These testing laboratories evaluate the splice caps for their ability to withstand voltage surges, temperature variations, and mechanical stress, as well as their resistance to corrosion and other environmental factors. When selecting a splice cap for grounding conductors, it is important to consider the size and number of conductors being connected, as well as the voltage and current ratings of the circuit. The splice cap should be properly sized to accommodate the conductors without overcrowding or damaging them. In addition to using listed splice caps, it is also important to make sure that the grounding conductors are properly stripped and cleaned before being inserted into the splice cap. The conductors should be free of any insulation, dirt, or corrosion that could interfere with the electrical connection. Once the grounding conductors are inserted into the splice cap, they should be securely crimped or twisted together according to the manufacturer's instructions. The crimping or twisting action creates a tight mechanical connection that ensures good electrical contact between the conductors. After the splice cap is installed, it should be visually inspected to make sure that the conductors are properly seated and that the connection is secure. Any loose or improperly installed splice cap should be corrected immediately to prevent potential electrical hazards. It is also important to ensure that the grounding bus in the subpanel is properly bonded to the metal enclosure and connected to the main grounding electrode system. The bonding connection should be made with a suitable bonding jumper that is sized according to the requirements of the National Electrical Code. The main grounding electrode system typically consists of a ground rod, a ground plate, or a metal water pipe that is buried in the earth. The grounding electrode provides a direct connection to earth, which helps to stabilize the voltage of the electrical system and provide a path for fault current to dissipate safely. The National Electrical Code specifies the minimum size and type of grounding electrode that must be used for different types of electrical systems. The size of the grounding electrode is determined by the size of the service entrance conductors, which are the conductors that bring power from the utility company to the building. In addition to the main grounding electrode, the National Electrical Code also requires that all metal enclosures and equipment be bonded together to create a continuous electrical path. This bonding helps to minimize voltage differences between metal parts, which can reduce the risk of electrical shock. Bonding jumpers are used to connect metal enclosures, equipment, and other metal parts together. The bonding jumpers should be sized according to the requirements of the National Electrical Code and should be securely fastened to the metal parts using approved connectors. When installing grounding and bonding systems, it is important to follow the requirements of the National Electrical Code carefully. Failure to comply with these requirements can result in a dangerous electrical system that poses a risk of electrical shock and fire. It is always recommended to consult with a qualified electrician when installing or modifying electrical systems. A qualified electrician has the knowledge and experience to ensure that the work is done safely and in compliance with the National Electrical Code. In summary, connecting multiple number 14 grounding conductors together using a listed splice cap inside a subpanel and then extending a single number 14 wire to the grounding bus is permitted by the National Electrical Code, provided that the splice cap is listed for the application and all other applicable code requirements are met. It is important to follow all applicable code requirements and to consult with a qualified electrician when working on electrical systems. Grounding is very critical and important for a safe environment. Firstly, grounding ensures electrical safety by providing a low-resistance path for fault currents, minimizing the risk of electric shock. Secondly, it stabilizes voltage levels, preventing damage to sensitive electronic equipment. Thirdly, grounding helps to reduce electromagnetic interference, improving the performance of electrical systems. Fourthly, it protects against lightning strikes by providing a path for the surge to safely dissipate into the earth. Fifthly, grounding improves the overall reliability and longevity of electrical equipment. Sixthly, it is a fundamental requirement in electrical codes and standards, ensuring compliance and safety. Seventhly, grounding facilitates the proper operation of overcurrent protection devices like circuit breakers and fuses. Eighthly, it prevents the buildup of static electricity, reducing the risk of electrostatic discharge. Ninthly, grounding enhances the efficiency of electrical systems by minimizing energy losses. Tenthly, it provides a reference point for electrical circuits, ensuring accurate measurements and control. The National Electrical Code, or NEC, is a set of standards that are widely adopted in the United States for the safe installation of electrical wiring and equipment. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and bonding. It is intended to protect people and property from electrical hazards. The NEC is not law in itself, but it is often adopted by state and local jurisdictions as part of their building codes. This means that electrical installations must comply with the NEC in order to be considered safe and legal. The NEC is organized into chapters, articles, and sections. Each section contains specific requirements for electrical installations. It is important to understand the structure of the NEC in order to find the information you need. The NEC also includes a number of tables and examples that can help you understand the requirements. These tables and examples are often used to clarify complex concepts and provide practical guidance. When using the NEC, it is important to consult the latest edition. The NEC is updated every 3 years to reflect changes in technology and best practices. Using an outdated edition of the NEC can lead to unsafe electrical installations. The NEC is a complex document, and it can be difficult to understand all of the requirements. If you are not a qualified electrician, it is recommended to consult with one before working on electrical installations. A qualified electrician can help you ensure that your electrical work is safe and in compliance with the NEC. The grounding electrode system is a critical component of an electrical system. It provides a low impedance path for fault currents to return to the source, which helps to quickly trip a circuit breaker or fuse and prevent electrical shock. The grounding electrode system also helps to stabilize the voltage of the electrical system and protect against lightning strikes. The grounding electrode system typically consists of one or more grounding electrodes, such as a ground rod, a ground plate, or a metal water pipe. The grounding electrodes are connected to the earth, which provides a low resistance path for fault currents to dissipate safely. The NEC specifies the minimum size and type of grounding electrode that must be used for different types of electrical systems. The size of the grounding electrode is determined by the size of the service entrance conductors, which are the conductors that bring power from the utility company to the building. The grounding electrode conductor is the conductor that connects the grounding electrode to the electrical system. The grounding electrode conductor must be sized according to the requirements of the NEC and must be made of copper or aluminum. The bonding system is another critical component of an electrical system. It connects all metal enclosures, equipment, and other metal parts together to create a continuous electrical path. This bonding helps to minimize voltage differences between metal parts, which can reduce the risk of electrical shock. Bonding jumpers are used to connect metal enclosures, equipment, and other metal parts together. The bonding jumpers should be sized according to the requirements of the NEC and should be securely fastened to the metal parts using approved connectors. When installing grounding and bonding systems, it is important to follow the requirements of the NEC carefully. Failure to comply with these requirements can result in a dangerous electrical system that poses a risk of electrical shock and fire. It is always recommended to consult with a qualified electrician when installing or modifying electrical systems. A qualified electrician has the knowledge and experience to ensure that the work is done safely and in compliance with the NEC.